welcome today. My name is Lejeune. I'm the CEO for Microscopy Australia. And for the last couple of weeks, almost months, we've had Laurence Lejeune, who's been visiting here. She's a PhD student from the University of Quebec in Montreal. And so she's been doing some of her PhD studies, looking at and reporting on the impact of distributed research infrastructures. So without any further ado, I will invite Laurence to start sharing her screen perhaps and get us underway. But before I do, just want to acknowledge that I'm joining you today from the lands of the Gadigal people, and want to pay my respects to their long tradition of learning and knowledge over many years, which we benefit from still today, and acknowledge the lands that you might be on, that you're joining today's meeting or today's webinar on. So Laurence, over to you.
Thank you so much, Lida. Thank you for the introduction. So hello, everyone. I'm really pleased to be here. This is my last few days in Australia, so I've tried to enjoy as much as I can. So I'm going to share my screen. Please, Lisa, let me know if it is showing the right screen for presentation. Hold on. So do you see the right screen?
Yep, now it's in presentation.
Yep. Okay, perfect. So, the topic of my presentation is from backbone to breakthrough, recognizing scientific platform contributions. So first, I want to explain why I do what I do, and to explain my journey to impact assessment for scientific platforms. I have been doing research for many years back in the day, and along those years, I got involved, especially since I arrived in Canada, into being founding members of different groups. One is the Canadian Cytometry and Microscopy Association, which I created with a colleague in 2005 and still working today. And I was president for a few years. In 2016, realizing that the needs for a scientific platform community were broader than just one technology, with colleagues, including Claire Brown, we created the Canadian Network of Scientific Platform, and I was vice president up until 2022. I'm also involved in a European group of advisory role in the core technology for life science, and also now I'm a co-chair of the Impact Working Group at Global BioImaging since 2022. In terms of professional commitment, I'm not explaining all my roles in my life, but the two ones that are really relevant to what we're going to talk today. So I've been a facility manager for over 10 years in flow cytometry in Canada. And I became involved in impact assessment by participating in various research projects or consulting projects since 2019. So the one that really got me hooked into a PhD is we got funding in 2019 by a federal agency, NSERC in Canada, to study the impact of research infrastructure. And I discovered a new field of research, science, technology, and society, which is really related to social sciences, which was very new to me. And I got hooked into that research, understanding that there's a lot that can be done to really understand how scientific platform and how we organize can shape and change the way we do research. So that was my biggest motivation. So first, I would like to give you the definition, one of the definitions that we can have for scientific platform that becomes kind of recognized internationally. So a scientific platform is a centralized shared laboratory which can allow for economy of scale. It harbors specialized instruments and can offer specialized services with dedicated experts, platform scientists that can usually cover multidisciplinary science. It's usually open to the community, so the type of access can be different from platform to another, but it's usually quite equitable access to make sure as many people that need to have access to the technology and the expertise are accepted. It needs to be discrete units in a dedicated base with dedicated instruments. All of that you need to keep in mind that a scientific platform is always embedded within a system that provides different resources for it to work. So of course you need to have the experts, the platform scientists, but also some of the human capital comes from the users and come also from the application specialists in the companies. You of course need to have equipment, can be instrumentation, in some cases reagents, processes, and specimen, depending on the type of platform. And to support those main two visible aspects of your platform, you need, of course, the physical infrastructure, lab space with environment control, air, gas, electricity, etc. Depending on the technology, can be more or less demanding. You need to have digital infrastructure for IT, research data management, specialized software. In the era of big data, this is becoming even more and more important. And also an administrative infrastructure to support the business models, the management, the finances, and the policies. Okay, sorry. So I'll go next here. So the platform have two main missions in general. Again, it's a big overview. It can have exceptions. You have a research support mission and a management mission. Whoops, what's going on? Okay, sorry, there's been a little hiccup. Going back to my slides.
That's all right. Yep.
I don't know what I did. Too enthusiastic. I suddenly touched a button I was not supposed to touch. So in those two missions, so for example, the research support mission, you help to implement new technology, making sure it's done with the appropriate quality controls, sometimes develop SOPs, ensure knowledge transfer by doing tons of training, general teaching sometimes, allow access with different rules and make sure that your usage is optimized, and also usually to run scientific consulting. In terms of management, you have, of course, operational management, booking of the instrument, making sure you monitor the users, take care of the budget, making sure the people working in the platform are happy. And also another aspect that is very, very important, but sometimes not always evaluated, or people don't realize, is strategic management. Whether you need to understand the institutional strategy, and part of the institutional strategy and the institutional policies that sometimes, depending on the type of platform, can go even to the regional or national strategies. So of those different missions, the backbone, we have some aspects that are very visible to your users and stakeholders, and some aspects that are quite invisible. So the one that are highlighted in yellow, usually people understand really well. The platform helps with the QC of the instrument. They train you, so you train the users, so they see you. You make sure that people have access to instruments, so they see that as well, and they understand that they have to pay, that there's booking, that there are organizations, that is usually visible. Many other aspects is kind of part of the privilege of having a platform is kind of invisible. So when you're in a privileged situation, many aspects are given, and it's not necessarily understood that it's actually very important. Like the fact that you accelerate new technology adoption, that having a high level of quality control and assessment gives really good quality data, that you support teaching in many different ways, not just one-on-one user training. It could be also from the management side, part of the strategy is very important, that you make sure that you work on a budget. So there's lots of aspects that are taken for granted, sometimes that are very important. So another aspect of scientific platforms in the recent years, it's like, and it's for you, it's very familiar in Australia because of increase, and I will talk to that in a minute. But in some places, infrastructures are kind of isolated, and there's not always a possibility to connect with others. But having that kind of connection exists in Australia. So, for example, the increase scheme. I've learned that new word which is very Australian. We don't say scheme in Canada. That allows to have different strategic approach to technology or disease priorities and national priorities that are financed directly. So, for example, Microscopy Australia can support many different imaging infrastructure. So you have 9 infrastructure across the country and 9 mixed labs. So that helps really to strategize for a country and make sure important technology can be accessible to most of the research community, especially when it's unique or very expensive. But in addition to providing funding or co-funding for those initiatives, there's also support of Microscopy Australia for many of those invisible tasks, which could be measuring impact, could be highlighting success story, and so on and so forth. I mean, Lisa will know better than me how to explain that, but that's a very important thing. Other initiatives worldwide. So in Europe, for example, you have a very strong network of platforms that are embedded into the European Research Infrastructure Consortium. Sorry for my pronunciation, Eric. And they span into 5 different big areas in energy, environment, health and food, physical science and engineering, and social and cultural innovation. So it's funded by the European Commission, and some of the money also comes from different countries. So an example that is a bit similar in spirit than Microscopy Australia is Global BioImaging, where you have, I think this is one of the most recent maps that I managed to access, are based in very different countries. So each country can have different facilities, and they can regroup as hubs. So for example, in France, maybe you have different nodes, but they're usually under France BioImaging, for example. So they're substructure within each country, so they can help be organized. But they provide visibility, like the fact that you're in Euro BioImaging provides visibility, provides resources, funding, and so on and so forth. So in Canada, unfortunately, we don't have a nationally funded distributed infrastructure scheme. We have major research infrastructure that are funded. So it could be a synchrotron, the Canadian light source, so things that are really, really big, like at the far end of spectrum, and really need a big investment. But there's no national strategy like you could find in Euro BioImaging or Microscopy Australia. So we did it ourselves by creating the Canadian Network of Scientific Platform. And this is key in platform scientist community, that when there's a gap in what we can do, there's a lot of move to do it by ourselves, like create something that will answer our needs. So far we cover most technology in Canada, and covered 234 scientific platforms, which are about 30% what's available there. So hopefully we'll be able to get more members in the future. So why is it important? We will talk about that in a few minutes. So why is measuring impact important? I'm sure if I were to open the mic and ask every single one of you why it's important, we will come with very, very different answers. Maybe some will be common, but so I will show you my perspective. And again, it can be discussed, and that would be fun to hear what your opinions are and ideas after. So measuring impact, you need to really put yourself in the perspective of your platform, so you can look different ways. And within a platform, you have 3 different types of impact. The ones that are direct, so things that you directly do in your platform. So for example, you produce standard operating procedures that are used by everyone. You train people, so you can document how many people you trained. You can document the type of technology you adopted. Some can be very unique, can be customized, can be, unique regionally, nationally, internationally. So this is kind of things, again, it's not exhaustive that we can document. In terms of indirect, and this is usually what stakeholders are interested in, is the type of research you enable. So it can be, of course, you have a distributed contribution to research, to PhD thesis or master's thesis. You contribute to different strategies as well that can help, for example, your institution to be more visible or to be more attractive. There's another layer of contribution that's even more remote, where you look, and this is why I wanted to introduce networks of platforms. What does your platform contribute to internationally or nationally? Are you part of an international group that publish standards or guidelines? Do you have distributed impact on multi-center projects? Could be international projects, could be national projects. Again, those kind of remote impacts sometimes are a bit more difficult to put your fingers on, but it is very important. And it's becoming more and more prominent right now because the community is being more aware of what they can do. So why is it important again? So we need to, it needs to be customized for each scientific platform or institution. And by doing our research in 2019, we realized that the classical indicators for research success, publication, grade success, etc., are not really adequate for the mission and vision of scientific platform. So we need new indicators. And of course, there's no one size fits all because each platform might have different constraints or expectations. Most of the time, the measurements will be indirect, quantitative or qualitative information. In terms of stakeholder, they need to have metrics for your institution, for your funders, for the policymakers. So you need to choose the right indicator that really talks about your mission and that really fits what you're doing. And of course, and this is one of the important points by being in networks, is to educate your stakeholders, for them to really understand what a scientific platform does or a distribution network of platform does. But of course, we still need to do it, even if sometimes it feels like you're under the scrutiny. We are accountable for the public that funds research. And it's a very big point in terms of policy making to make sure that research funds are used the best way possible. And this is a quote from Einstein, and I checked, it's a real quote from Einstein, not a made up one. So many of the things you can count, do not count. Many of the things you cannot count, don't count. So keep that in mind. So always interesting to take a step back and to see the perspective you're in. So again, you're in a platform, you need to align for the vision, mission, and values of scientific platform. And sometimes people don't really know what they are until they think about it a little bit. Sometimes it's very clear. So if you are an institutional facility with outside access, and there's a lot of them out there, we don't care, of course, to know how many external users, because this is not what's important for that specific facility, but you need to have a very good understanding of the internal lab using the facility. If you're, for example, a Nikon imaging facility or a Microscopy Australia facility, the internal users might not be as important because maybe it's not part of the mission. I mean, they're important, of course, but you need to know maybe how many external labs we're able to access if it's part of your mission. And from the stakeholders' perspective, you need to align with their interests. So, for example, if it's a cancer foundation that funds your research, I don't think they care about the number of students you trained, but they will really be interested in the new therapeutic targets identified. But if it's a federal government funder, and here is an example very typical of Canada, they're very interested in hearing about the number of graduate student trained, so the highly qualified personnel, and the job graduate student gain after graduation. So these are the types of things that you need to consider. It's not easy to measure. So how do we do that? So again, we go back to the vision, mission, and values. We need to choose specific indicators that reflect the scientific platform, institution, vision, mission, and value. I know I repeat that a lot. Why I do that? Because indicators, numbers, must be placed in the context of a story and not be the story itself. And it's very easy to focus on numbers, and there's very lots of stories around that. I should have put my little favorite cartoon around that, but numbers are a tool to support a story. If you just put numbers, that might be becoming the story, and it's usually not always in your favor. It might bring problems. You need to measure your strengths, but you also need to measure weaknesses and gaps. Strengths is great to showcase success, but looking at weaknesses and gaps can help to identify areas to improve, illustrate gaps to fill, and it's not supposed to compare with different platforms, because each platform is very different from one another. And the reason I say I'm measuring weakness and gaps, despite being uncomfortable sometimes, can really help you, in fact. If, in my case, personally, I had a time in my professional life where I was so busy, so overwhelmed, people had to wait for 2 months to get able to get self-sorting. So I was able to use those red flags to say, guys, we really need someone else to help me. Or I need a service contract so that it can be done faster, things like that. And it can really be used at your advantage if it's done properly. Of course, it can give you a sense of evolution over time. It can help us a history and future vision of the scientific platform. So you get assessment regularly, so you know how you user-based change, what needs are, etc., etc. It depends on the life cycle. You don't ask the same thing of a very nascent facility versus a mature one, or even some facilities that might need to be decommissioned. And again, the indicators can be both quantitative and qualitative. Same quotes again. And another thing that makes it difficult for platform is if you're in your lab, you have your projects, so you know the impact you have on your projects. If you're in a facility, you have many different types of impact that are very distributed. So you support hundreds of projects usually. So it's very difficult to visualize the micro impact you have in each project. It's possible, but it's difficult. Same thing with technology. Usually a big platform will support different technologies and different applications using those technologies. Will interact with different vendors, different manufacturers, sometimes work with prototypes. So you also interact with people that have a different language as a scientist. So it's a challenge, but it's also an opportunity. You can train and educate lots of different people, so you can ensure science is down to the best practices. You're also some kind of an interpreter because of your transdisciplinary nature of your work. So this is a challenge, but this is something very unique that should be used and nurtured in the ecosystem. So with that in mind, back in 2020, we published with Global BioImaging, and because of the funding from Encircle Albert to really dedicate resources to do that work, we published a national recommendation from Global BioImaging for measuring imaging for facility impact. And again, it could be different technologies. So there's two aspects. So we talked about KPIs with 3 areas: infrastructure and personal, scientific platform performance, and financial performance. And indicators, socio-economic indicators, SCIs, on 4 areas: resource, HQP, collaboration and innovation, and public visibility. So for the KPI, we have 10 different aspects. One on personal infrastructure, so to measure, to evaluate what's in the facility, the performance, facility users and diversity of the users, their training, the satisfaction. It has direct publication from the facility or indirect publication, whether in acknowledgement of authorships, and also the financial performance. So to give an example, we also highlighted the difficulty to measure with 3 colors. Green being, oh, it's easy to do. Yellow being, you have to work a bit on it. And red, see, I still don't know how to do it. So the green one, so for example, usually you have example for the infrastructure where you usually know the number of instruments that you have and you know what they do and you know how they use. And you also know about the user base. But if you want to know if the instrumentation you propose is unique, whether locally, in your city, regionally, in your state, or nationally, sometimes internationally, you need to know what's around you. And it's not always that easy to have that information. Another one, and that Canadian Climate is really interested about those kind of things, is that jobs facility users find based on the influence of facility training experience. And I'm currently working on a project where we try to track that kind of things. Where we try to figure out who are the users, what's their career path, try to get interviews with them to understand if the fact that they use a poor facility had an impact or help them in their career. So it requires lots of resources to do that. Now, if you go to the socio-economic indicators, there was 4 areas. One about resource, so do you share data? Do you develop standards and quality management? Education resource for the larger community, for example, PowerPoints, books, videos like we do today. And do you give expert advice to support public policies? For the personal, do you do public education? What are the specificities of the imaging scientists? Do you have unique skills? Do you support job creation? Collaborative innovation, of course, has this aspect to work with industry that can be very strong, that can be in very high demand, and sometimes it's very highly expected, depending on the different platform and the countries. And sometimes the visibility in the media also can be important. Again, 3 colors. So here I just give a couple of examples, especially for the imaging scientists, and something that we also take for granted sometimes. So it's relatively easy to say how many platform scientists you have in your facilities. Maybe you know what their degrees are or things like that. But now if you wanted to go to the professional development of imaging scientists to know what are the unique skills, do they program? Do they know how to work with atom probes or to repair instruments? Or did they follow up management course? Did they follow up specific course that make them unique and have skills that are not necessarily reflected at all by the degree or the title? So that can be a bit tricky to do. But that can have a lot of value because this is, you usually can demonstrate the uniqueness of your instrumentation. How do you demonstrate the uniqueness of the staff you have, of the experts you have? So numbers are not enough. As I think I've said that quite enough. You need to tell your story. So Global BioImaging, I wasn't part of that working group, but I want to highlight it anyway, is an added value document. So often when you talk with people in platform, I'm sure it's the case in other jobs, but in platform, they don't realize the value they have for others, for themselves, for the users, etc. So having that kind of document really helped a lot of people, including myself, to visualize and understand what is our value added. So for example, for the scientists that are part of, that are using the facility, they have access. Just the term access is very important. They have access to infrastructure and expertise. And they have access to quality training and education. For institutions and funders, it's equitable access to researchers. So for an institution, it's a very big attractive point for new researchers and students. It can quick start early career researchers and extend the life of advanced infrastructure. I should forget to use that word anymore. It's a platform. And the extended life comes into also the sustainability of the infrastructure and good management of the money. For the staff, for the people, the experts in the facility, they have a chance to work on diverse research projects, and they can network with the global imaging communities. I mentioned earlier in my figure that the people that are expert, they are really their node of collaboration and interaction. So it's very important. And for manufacturers, and I can tell you, I did work for a company for a few years that was selling high-end instrumentation. Having access to core facilities and their expertise, it's direct contact with diverse research base. Then you're sure you have optimal installation and operation of the instrumentation. Sometimes core facilities are beta testers, and it's very high value for the manufacturers. So tell your story. So again, if you're going back to adapt your story to the mission and vision of your facility. So if you go for the user's perspective, you train the next generation of scientists. From the platform scientist perspective, you need to showcase your unique expertise. Sometimes, again, you take it for granted, it's a given, but I'm sure if some of you take a step back and reflect, you have things that are unique that could be showcased. For technology, you accelerate technology adoption, you can help technology development, sometimes in collaboration with industry, sometimes within your research community when people, researchers try to build new instrumentation, etc. And you can work a lot in application development as well. You can also make sure people are happy by collecting feedback and help with continuous improvement. And collaboration platform can become a collaboration hub because you know what everybody does and you can connect the dots. And it is something that most of us do naturally, but it's of high value and can become a way to increase even more the impact of what you're doing. And of course, good quality data with a good laboratory practice, it's strong integration, and data management, for example, are their principle. And from the stakeholders' priorities, your users, they want new application, they want support, they want ease of use, they want access, they want professional skills development. I'm sure we can add a few dots there. For the institution, they want to have research quality, they want to attract students, and I talked to a few universities what they do first. When they have new scientist students coming in, they make the facilities of all the new fancy instruments is very attractive. For new researchers, if they can start their research right away, it's a very strong attractive point as well. So it allows them for research acceleration. And we all know from a researcher's perspective, being able to work faster makes them first to publish. So having a higher citation rate, so they're happy. For the funders, depends on what they ask. Okay, so it really depends on the strategy of each funder, or the strategic priority of each funder. But we can show that the platforms are a collaboration hub. It's connected with other. It can promote equity, diversity, inclusion, etc. So you need to know your funders. Policymakers, impact on society. We can cure disease, and we had very nice stories in COVID time of platforms being able to flip what they were doing. For example, a genomic platform was able to do testing, do tissue culture, or do masks for advanced fabrication. So there's the fact that it was platform really helped to support the COVID the pandemic effort, etc. etc. So for publisher, having open science is great, having good quality data is great, international guidelines, international standards, methods, etc. is, by the way, methods articles family are the ones that are the most cited, just to let you know. Another fine initiative that I find very, very interesting is a microscopy. Of course, I forget the name of it will come back to me later. But you have people from all over the world with lots of different backgrounds that are involved in the imaging community in different ways. Some are director, manager, staff, working around those lines. And in Australia, you need to talk to him. I need to find his name. like Ruiz called.
Is it Peter O'Toole?
Yes, thank you.
Yeah.
I know his name, of course, and of course, the minute I talk about him, I forget. Thank you, Lisa. Peter O'Toole. So he did, it's very, very interesting interviews, and it shows lots of different career paths, lots of different point of views. So it's really, it's quite entertaining. So it's just about science. And Ruiz Cole did one. So if you want to go on their website, you'll find it. So breakthrough. So we talked about many different ways to show your value and to show your impact. I just want to highlight a few things that I think are breakthrough. It's just a few examples, and I hope to be able to show more in the future. One that I found very interesting in terms of methodology, Natural Research published a special issue report about reporting and reproducibility in microscopy. And this issue was fed by many articles coming from the community. And this really highlighted the need for better quality data, better quality imaging, microscopy, and having a way for everybody to work along the same, harmonize the way people work. And this, I think, reflects the kind of impact a community, a network of scientists, platform scientists can have. Another one is Quarepimi, again, along the line of standardization, harmonization, etc. Is a community that endeavors to advance quality assessment and reproducibility in microscopy. So just to give you, so it's covering lots of geographies, not lots of certain places, but it's changing. Like as time goes by, there are more and more people involved. But just to show you the distribution, so majority of participants, like a big number of participants are coming from companies. There's lots of groups from academia, so Microscopy Australia is part of it. And there are also standards like ISO, NIST, etc., from different countries that participate as well. So it's from the conception of that group, it will change the way research is done, whether it's the metadata in the instruments, whether it's a type of image format, whether it's data management pipelines. There's lots and lots of initiative around that, but it's done with all the important key players. So this is what core facilities platforms community can do. Another one that I really like, and it's a different type of impact. It's not necessarily something that could be considered straightforward for most people, but this is amazing story and structures exhibition that explores images that pass on knowledge and shape our understanding of the world. It has rich visual parallels between the representation seen in many indigenous artwork and the microscopy structures hidden in the natural world that reveal unexpected and intriguing similarity. So on a side note, in Canada, there's we just learned recently that we might be able to fund a project like that in Canada. So I'm really, really happy that we have high chances that's going to happen. So this is the kind of things that can help connect with general public, with art, with lots of different things I find amazing. And to finish my presentation, tools to measure impact. Again, there's lots of tools out there that nobody knows about, right? So this article is one that has been published by Phil Hochberger's team in Northwestern University. But I know that by having discussing with people in Australia and other countries, that there are other groups or institution or networks that do have very, very advanced methods to measure the impact that hopefully maybe some are part of the organization, some are kind of not necessarily public. That would be very interesting too. And this is kind of the thing we try to do with Global BioImaging too, is to kind of get away from general suggestion that we did in the recommendation, but be more specific in how to do it, have modules, training modules, and so on, and how to do the many things that we suggested today. Another very interesting thing is we mentioned that working with research you have to demonstrate that you enable some research with your facility in certain geographies. And for that, you need to be acknowledged, and you need or being co-author. And for that, the Royal Microscopy Society did publish a poster with the kind of condition saying, oh, if you do that, it's more an acknowledgement. If you do that, this is more a co-authorship. And it's somehow based on the credit contribution framework that has been published a while ago by PLOS ONE. And now, recently, like in the past few weeks, actually, Global BioImaging launched an initiative that people can post that, like literally post that in their facility. So this is typically an initiative that is really coming from the community. Some institutions don't really have a policy because they don't know about the challenge of being recognized as a platform scientist, or they don't care. Some it's because it's a big thing, it takes too much time. So coming from the community, lots of groups did already posted. So you have, for example, I didn't put everything because there's tons of things that have been happening in the past few weeks, but you have the ones in Singapore. This is McGill at University with Abif and Claire Brown. This is IC, which is Imaging Southeast Asia. Then you have WISCOL lab that also put it. So again, there's it's better for me. It's my advice: do it. Don't ask for permission. Just do it. And sometimes it's how things change. Sometimes it comes from the community. Another thing to make that happen, you need to have persistent identifier. So here is an example of type of identifier you can have. So for yourself, an ORCID ID, please, if you don't have one, do it. It's really, really useful to, the reason is not necessarily to put your name as a co-author, but it's really helpful to find you in the bibliography, because people have same names. I have 5 or 6 Laurence Lejeune out there that do publish, and it's not me. So it's very complicated for certain names because they have lots of them. So having an ORCID ID makes sure we can find your publication, your citation, etc. Same thing for data, publications with the UIs. For organization funders, you can use RID, which is more North American solution. It's AOR, and you can also use grant ID with Crossref. So again, it's not exhaustive. There's other solutions. So you need to be sure it's public, open access, etc. It's right to use that, but it helps you to track and monitor and document things around. And finally, and this is my conclusion, telling your story. And this is something I will always repeat: what you do matters. You need to be confident, and you do more than you think also. You do more than you think. Be confident, start by grabbing attention, and telling your story has an impact. And thank you, everyone. I want to thank, I was able to come to Australia because of the Social Science and Humanity Research Council of Canada that gave me a grant for a scholarship to be able to come here, and my university, my research center, and Global BioImaging. Thank you.